Hello, Matt here from chemistrystudent.com. In this video, we're going to look at the nitration of benzene. We're going to talk about what the nitration of benzene actually is, outline the steps in the mechanism for the reaction, and look at how the electrophile we need can be made. The general structure of benzene and the general electrophilic substitution mechanism of benzene are outlined in separate videos. Check the links in the description below. Before we talk in detail about the nitration of benzene, there are a few essential ideas you need to be comfortable with. Benzene is a cyclic hydrocarbon with a delocalized electron system that reacts with strong electrophiles in electrophilic substitution reactions. It is essential you are comfortable with this general mechanism in order to follow the rest of this video. If unsure, please check the link in the description below for the video that outlines this in more detail. Electrophiles are electron pair acceptors. They are usually positively charged and are attracted to areas of high electron density. A substitution reaction is where one group or atom in a molecule is swapped for another group. And acids are H+ donors and bases are H+ acceptors. Sulfuric acid and nitric acid are both examples of strong acid, with sulfuric acid being a stronger acid than nitric acid. This just means that sulfuric acid is better at giving H+ ions away and forcing other substances to accept them. So recap done, let's go. When benzene undergoes nitration, nitrobenzene is formed. An NO2 or nitro group is substituted for a hydrogen bonded to a carbon atom in the benzene ring. We know that benzene reacts via electrophilic substitution following a standard mechanism. The key area of focus of this particular reaction is how we generate the NO2 or nitro group electrophile, although you do also need to be able to know the mechanism as well. So to form an NO2 electrophile, a mixture of concentrated nitric acid and concentrated sulfuric acid is used. Remember in the recap we said that sulfuric acid is a stronger acid than nitric acid. This means that in a mixture of the two, sulfuric acid can actually force nitric acid to act as a base and accept H+ ions. If this happens, H2NO3+ or nitrooxonium ions are produced. These ions are highly unstable and rapidly break down into nitronium ions, NO2+, and water. There are a couple of different ways this can be represented, but here we will consider it as two steps. First, the nitric acid acts as a base, accepting a H+ ion from the sulfuric acid and forming a nitrooxonium ion. Then the nitrooxonium ion breaks down, causing an NO2+ or nitronium ion to be produced. It is this positively charged nitronium ion that is able to act as an electrophile and react with benzene, providing the NO2 or nitro group that we need for the nitration. The reaction with benzene now just proceeds as expected, electrophilic substitution. A pair of electrons from the delocalized ring of electrons in benzene is used to form a bond between a carbon atom in the ring to the nitrogen in the positively charged nitronium ion. This breaks open the ring of delocalized electrons and forms an unstable intermediate. To reform a full ring and get back some stability, the carbon-hydrogen bond on the same carbon as the carbon-nitrogen bond will break. The electron pair is put back into the delocalized system and a H+ ion is removed. This leads to the formation of our nitrobenzene. The H+ ion will be picked up by the hydrogen sulfate ion produced earlier from the reaction between nitric acid and sulfuric acid, effectively reforming sulfuric acid, and this is why we can consider the sulfuric acid to be a catalyst. A warm temperature, approximately 55 degrees Celsius, is needed for this reaction to occur. This is because the breaking of the delocalized electron system requires large amounts of energy due to its relatively high stability. So, to summarize, benzene reacts with a warm mixture of concentrated nitric acid and concentrated sulfuric acid to form nitrobenzene. The reaction is an example of electrophilic substitution, and a nitronium ion is created by the reaction of concentrated nitric acid and concentrated sulfuric acid. The sulfuric acid is a stronger acid than nitric acid and forces the nitric acid to accept a H+ ion, becoming a nitrooxonium ion. that rapidly breaks down into positively charged nitronium ions that can act as electrophiles and react with benzene. A lot of ions being mentioned there. Warm temperatures, approximately 55 degrees Celsius, are needed to overcome the high activation energy barrier to break the delocalized electron system at the start of the reaction. I hope you found this video useful. Please check out other relevant videos in the links given in the description below, and visit chemistrystudent.com for free notes and revision materials.